Since the last comparison of ChatGPT and Claude, new versions have come out, so let's do a refresh of that video. Which one is better at coding, Claude or ChatGPT? Anthropic themselves say that the new Claude 3.5 Sonnet delivers significant gains in coding. One new feature I already demonstrated in the last video is that you can now upload CSV files and also NPY files, so the native NumPy format. Claude will understand the data and then can adapt the code to it, which is interesting because even JupyterLab cannot open NPY files. OpenAI also has a new and improved version of ChatGPT, being OpenAI 01. So we're going to try to build a snake game and an Electron Cloud simulation in order to have a fair comparison also to the older versions of ChatGPT and Claude. We're going to use exactly the same prompts as last time. So I paid for the premium versions of both Claude and ChatGPT in order to get access to their latest and greatest versions. So if I spent that money in order to make these videos, you can leave a like, comment, and subscribe. I'm going to do it on the fly today, so as of this moment, I do not know how this comparison is going to end. Let's start with Claude and tell it to create a snake game in Python. I'm very curious now if we can get to the final version of the game in less prompts than last time. But also here in the updated version it tells you that Claude does not have the ability to run the code it generated yet. Alright, it looks different than last time. And we get a scoreboard. Let's see if we can do 180 turns. No, they're not possible. Oh. Did you just see the game crashed? So I just hit down left quickly and the game crashed. There's definitely still a bug in there. Let's go back to Claude and fix that. So I prompted when I'm going left and hit down right quickly, I immediately lose the game. Plus the game window just closes when the game is lost. We get the second version of the code. Now still, if I hit down left quickly, it ignores the left turn. So we don't collide with ourselves anymore, but it ignores rapid keyboard inputs, which is exactly the same problem we had last time. So we can reuse the same prompt to fix this problem. It seems to understand the problem, gives us the third version of the code. It's still ignoring rapid key input. Sometimes it works if I give it a little bit of time, but if I hit them in quick succession, it still ignores them. Which, by the way, is also exactly what we had last time. We had to prompt it multiple times. If you give it a little bit of a break in between, it will react, but if you do it fast enough, it will ignore them. Let's give Claude one more try to fix it, otherwise we give up and the old version of Claude will actually be better. We tell it still ignores rapid keyboard inputs if you do them fast enough. This looks a lot better. We can have rapid keyboard inputs and they're not being ignored. Also no 180-degree direction changes are possible. Let's play the game a little bit to see if there are any other issues. Alright, game over with a score of 25. Everything seems to be working and we can even press space now to restart. The only thing we can't do is quit the game with a keyboard input, so we just have to close the window. But I'd say that's okay. Did you just see that? The food was spawned inside of the snake, which shouldn't happen. So that is something we still need to fix, but I actually checked it also the last time we made this comparison. If you play long enough, this will happen. So here, it happened again. Let's try to fix that and also add a keyboard shortcut to close the game window. So we prompted the food sometimes spawns inside of the snake when the snake is long enough. Also add the keyboard shortcut Q to close the game window when it's game over. It says it fixed the code. Let's try it. Let's see. We need to play for a bit for this problem to appear. I messed up. But now we can try closing the game window. That works, so we can restart it. Interesting. I just hit down left and it appears like we just collided with ourselves. So the food spawning problem is gone, but something odd just happened. So I tell it when going right and hitting down left quickly enough, I just collided with myself and the game was over. So the rapid key inputs still work, but they don't cause self-collisions. So everything seems to be working. Alright, I just played until a score of 74 and I couldn't find any other issues. I think we're good. Still took us 7 versions to get to a playable game that worked perfectly, but to compare it with the old Claude 3.5 Sonnet, we needed 6 versions to get where we got today in 5. So Claude did get a little better, but not dramatically. Let's do the same thing in ChatGPT and see what we get. We're using the ChatGPT 01 preview version, and remember in the last video with ChatGPT 4.0 we could not get Snake to work, so let's see if this one is better. It actually gives us 2 responses, and it tells us that it thought for 19 seconds. So basically the main new feature of ChatGPT 01 is that it can prompt itself, so it can think longer. It didn't actually get more intelligent, but it takes more time to think about a problem. So let's try both versions, see what we get. Here 180-degree direction changes are possible, which shouldn't be, which means we can probably collide with ourselves once we're long enough. Yeah, Let's try the other version. This one already looks a bit different, but also here 180-degree direction changes are possible. And we collide with ourselves. Neither one of them is working. Since it's the same issue that we had before, we can use the exact same prompt to try to fix it. The direction changes are still possible if you hit up left quickly enough. Same issue as before actually, so we can use this third prompt from last time. I can still produce that error if I'm going right and hit down left very quickly. Rapid key inputs are sometimes ignored. So we use prompt 4 from last time. It understands the problem and gives us new code. That actually looks good. No direction changes anymore and it doesn't ignore the rapid key inputs. I'm gonna play for a little bit to see if there are any other issues, but for now this looks really, really good. I was starting to think that GPT-01 wasn't actually that much better than GPT-4o because all the previous steps were exactly the same as before. But with this prompt, we actually fixed everything. So no direction changes are possible, rapid key inputs are possible, the food isn't spawning inside of the snake like it did with Claude. So in 5 prompts we actually got to a playable game. That took us 7 prompts in Claude. So today, ChatGPT wins the snake comparison. And if you want to have a complete course that goes beyond the basics, check out trainingscientist.com, where you can choose between on-demand courses with video lectures like this one, and live blended learning courses, where additionally to the video lectures, you also have Zoom meetings where you can ask me questions directly. Let's continue with the Electron Cloud simulation using the same prompts as last time. And we get a very interesting result. That in the beginning starts with some initial velocities and later almost looks like Brownian motion. But as a first step, not too bad. So now let's make those particles electrons that repel each other. This seems way too fast. And electrons don't stick to the boundary once they're there, which they should. Like last time, there's also some damping term that we don't want, and make the boundary non-bouncy. It still seems pretty fast, but at least the particles stay on the boundary now. But they seem to be passing each other inside of the boundary, so that we need to fix. Which, by the way, is also the exact same progression. So we can use the same prompt telling it that the electrons are going through one another, that shouldn't happen because of the electrostatic force, that the time step might need to be smaller, and to add a slider to the plot where we can change the simulation velocity. Similar issue as last time, now it's almost too slow. And also here the electrons pass through one another. So something definitely still isn't right. Let's see what the slider does. Okay, we get a factor of 2. It's interesting. Particles can still escape from the boundary, which shouldn't be possible because all the particles that are inside should be pushing them to the boundary. And since there are no particles outside that would push them back, they should stay there. But that doesn't happen here. So we use a similar prompt as last time to make the time step of the simulation independent of the slider. The time step should always be small. The speed slider should just speed up the animation, and the particles should stay on the boundary. So it added some terms to the code, which I think are not really physically motivated. They seem to attract one another now. Something odd is going on. Plus they still don't stay on the boundary. This would generally be the point where I give up, because we're not really getting closer to the solution, and it's just adding more and more unphysical terms to combat other unphysical terms that are in the code. And we saw last time that ChatGPT 4o already gave us a version that was working quite well. So let's switch to ChatGPT now, because we're 5 versions in and it's still not even close to what we want. So last time we had to actually copy paste the code from ChatGPT into Claude and then work with that in order to make it work. Let's see if we have to do the same thing this time. Remember, I didn't ask for electrons yet, just particles, but the movement already looks quite nice actually. So the first version for both Claude and ChatGPT is a lot better than what we got last time. Let's make those particles electrons. The simulation seems to be very, very fast, and some particles are even outside of the boundary. So we tell it the particle movement is really fast and some of the electrons end up outside the circle. I think the time step is too large. It seems to understand the problem and gives us new code, so it's a lot slower now. But the particles also don't stay on the boundary, they bounce off. But the electrostatic repulsion that they have seems to be implemented properly. Even for longer periods of time, the electrons don't end up on the boundary, so there's still something wrong here. Plus it would be nice to have a slider. So it understands the problem, but it now included an outward radial force, which I'm not entirely sure if that's what we want here, but let's try it out. So the electrons still bounce off the boundary, it looks better than before. But maybe we can do better than this. So I tell it, please don't add any forces other than the electrostatic repulsion to the simulation. Just make the boundary non-bouncy. Also make the time step of the simulation independent of the slider. That should only control the animation speed, not the physical time step of the simulation. Seems like it understood the assignment. Now the particles are barely moving. Let's speed it up a bit. But even at maximum speed, it's quite slow. Let's run it for a bit and see what happens. So we definitely don't see any bounce back from the boundaries anymore. So once the particles reach the boundary, they stay there. But as it seems they can still pass through one another on the boundary. We actually got to a decent result quicker last time with ChatGPT 4.0. So it's surprising to me that it takes a lot more prompts this time to get to a working simulation. So instead of making the time step smaller and smaller, we just change out the time integration scheme from the Eulerian schemes to the RK4 scheme. If you want some more information on that, check out the last video. And at the same time, we ask it to let us choose higher animation velocities. Let's increase the animation speed. But even here at maximum speed, it's quite slow. But the particles here did not pass one another. We might still have to make the physical time step of the simulation a little bit smaller to make sure they don't even get as close as they do. But as far as the simulation goes, I think we're good. Still being able to choose higher simulation speeds would be nice here, but I think we can work with that. Let's try out the last thing that ChatGPT last time could not do, giving us a counter that counts how many particles are inside of the circle and how many are already on the boundary, and doing that live on the fly. The counter for the particles inside the circle, a real-time graph, and higher animation speed. It gives us some user warning here, but it does seem to be working. So we have the number of particles inside. That is continuously going down, and we have the animation speed. So let's speed it up to the maximum. It's still quite slow, but at least the simulation seems to be accurate. And the particle counter also works. So let's leave it at that for today. Last time ChatGPT could not build the second graph, so we had to use the first solution of ChatGPT that was a working Electron Cloud simulation, take that code into Claude and let Claude do the rest. ChatGPT was only good at the first couple of steps and Claude could do the later stuff better, but today we can do everything in ChatGPT. ChatGPT wins today's comparison, definitely a step up, while Claude got a little bit better, but not a lot. If you haven't watched it yet, check out the complete Python course for beginners, where we install Jupyter Labs, set up virtual environments, introduce the AI tools, and look at some best practices, and a lot more.